All right, so we've just got a short lesson today on just kind of an extra grade 11 thing with exponents. So we are going to learn today how to switch from a radical form into an exponent form. If you have phones out still, can you just please put those away off your desks? Okay, headphones as well. Joey? Okay. Tamala, you just need to get in uniform as well. Okay, so any radical that we have, so whether it's a square root or any other root, this is a cube root in example 1, example 2 is a fifth root, any of these can be expressed as what we call rational exponents. And rational, what we want to think when we hear the word rational is fraction, okay? So we can actually switch between the two forms, either radical form or expressing these as like fraction exponents. Lauren, can you just grab the back door there for me? Thanks. Okay, so the most simple rational exponent that we can have and the most simple radical that we can have is just your basic square root. So there are a couple of things that we kind of just like understand in math, right? And some of those things are, for instance, if I put an x here, what do you guys know about the exponent of this x? It's just 1, right? So we understand if we don't write it that the exponent is 1. So we know that. Those are things that are understood. We also understand that there is a coefficient of this x, but it's not written here. There's no need for us to write it. What do we understand as the coefficient of this x if it's not written? 1. There's 1x, right? Okay, so with our most basic root that we can have, it's actually understood that this is a square root, right? And then everything else you'll see actually has a little number out front, like a cube root or a fifth root. So we can kind of imagine here that there's like a little 2. We don't need to write it because it's one of those things that's understood, but we should be aware that it's there. And also we should be aware that, of course, the exponent on this x is a 1. Okay, so I can actually rewrite this square root as a fraction exponent. And what we do is whatever exponent is on the x, okay, this will go on the top, and whatever value is out here will go on the bottom of the fraction. So when I rewrite this in rational form, it's x to the exponent 1/2. Okay, so imagining, for example 1, that there is an exponent of 1 on this x. When I write this as a rational exponent, it will be 1/3. Okay, and then similarly, so this guy has an exponent of 2 this time. So you essentially just like leave that exponent and then the value outside of the root becomes the denominator of the fraction. Okay, so that one's y to the 2/5. Any questions so far? Okay. Of course, if we can go from radical to rational exponent, we can also do the opposite, right? We can go from rational exponent and bring it back into radical form. So anytime you see an exponent of 1/2, we want to think of that thing as if it's a square root. Okay, and then some of these things we can actually just go ahead and evaluate, right? Like I can do the square root of 16 and just get 4 from that. Okay, this guy here, this is a cube root. Again, there's not any necessity for me to write this exponent of 1. We don't really write exponents of 1. So if the top of your fraction is a 1, once you change it into radical, you probably won't see it. But it's understood that that 1 is kind of up on that value, whatever it is. Okay, so I want to make sure that we know how to enter these into our calculators. We're used to entering in square roots. If you have a graphing calculator, you actually have to enter in exactly this into your graphing calculator. You actually don't have a root button that allows you to take different roots other than square roots. So if you have a graphing calculator, and anyone with a regular calculator can also do this, one option to evaluate this would be to evaluate it as 27 and then press your exponent button, whatever that is, and then just do 1 divided by 3 as your exponent in brackets. And that should calculate it for you. Okay, so I can calculate it that way. The other way that I can calculate this is some of you guys, depending on the calculator you have, you might have this button. Okay, that one's a nice button because you can just literally just enter in whatever numbers you want. Others of you will have an X root button. And what you're going to do is enter in the root that you want to take first. So I want to take the third root, and then I'll press that button, and then I'll enter in the number that I want to take the cube root of. So you just have to decide which one your calculator does. Okay? What should we get as an answer for this? We should get 3. Okay, so just make sure that you can get that using one of those 3 methods, depending on what your calculator is. Alex? Can you? Okay, so maybe some of the newer graphing calculators you can enter the root in. Tamala? This? Oh, well, sometimes we won't have a value that we're actually evaluating under here, so it's important for us to know how to switch between radical and rational. These ones have numbers, so obviously we can jump right to it if we're just calculating. Okay, and also it's important for us to know that sometimes we have rational exponents that can be reduced. So for instance, 4 divided by 2. What is 4 divided by 2? Okay, so it's not actually even necessary for me to express this in radical form, right? It's just 2 to the 2, because 4 divided by 2 is 2, and then we get 4 here. Okay, so we always want to try to reduce our fractions if possible. So far, so good? Any questions? Okay, so we're going to try a couple examples. Okay, so our goal here is to change these into rational exponents. Remember, no negative exponents in final answers. So this one actually has 2 variables in it, so I'm actually just going to take both of these exponents and put them over the root that's out front. So in this one, we'll get x to the 3 over 4 and y to the 2 over 4. Oops, I put x. Y to the 2 over 4. And then the last step that we need to just check is, do we have any negative exponents, and can any of these fractions be reduced? So yes, we can reduce the fraction. 2 over 4 can be reduced to 1 over 2. Okay, and that's it. Okay, what are we imagining is out front here if we don't see anything? No. 2, square root, right? All right, so we are putting both of these values over 2. Okay. So there's a couple things that we don't like when we're working with fractions. We don't like to have fractions inside of fractions like we have in that exponent of b. And then again, we want to make sure we don't have any negatives there. So I want to take care of this first. We're just going to do a little off to the side calculation. We'll do it down here. 4 over 3 over 2 is what we have right now. Okay? So what is the denominator of this 2? If I just have a number, what's the denominator of any regular number? 1. Okay. So this is really like 2 over 1. Now, when I'm dividing fractions, we talked yesterday about how we take the second fraction and flip and change to multiplication. So we can actually write this as a multiplication of the 2 fractions by flipping and multiplying that bottom fraction. Because it's 4 over 3, and then we have to put it over the value that's outside of the root. So we have 4 over 3, and then all over this root value. Okay, and I can cross cancel here before I multiply across. I will reduce both of those. I get 1 and 2, which just leaves me with 2 over 3 as my exponent. Okay, so if ever you need to just like do maybe some fraction work off to the side, that's totally fine. But just make sure you show your work somewhere. Okay, so here's what we've got. We've got a to the negative 3 over 2, and now we know that b has a simplified exponent of 2 over 3. And then my last step is just to eliminate any negative exponents. So I'm just going to take the part with the negative exponent and we'll bring it into the opposite side of the fraction compared to where it is now. So right now it's in the numerator. I want to bring it down into the denominator and we'll just make the exponent positive. So I don't flip the exponent or anything like that. I just change the whole side of where that base and exponent are in the fraction and it becomes positive. So that will be my final answer. And that's just some of our side work for this. Any questions for that guy? Okay, so now you guys know why I said that you need to have those fraction skills down, because now we're working with fractions and exponents. Not in a fraction, but in an exponent. Okay. This one doesn't actually have any rational exponents, but I think it's good for us to just do something like this. So notice that this whole thing in the numerator has a negative exponent. So I'm actually going to take this whole guy and move him down into the denominator so I can make that exponent positive. What would be left in the numerator is just a 1. So now I have 2z to the exponent 3 all squared to the positive 2. And then I have what was already in the denominator, of course. Okay, remember again that the squared applies to both things here. So I'm doing 2 squared and also z cubed squared. And anytime I have a power of a power, I am multiplying the exponents. Oops. So I'm not getting z to the 5, I'm getting z to the 6, doing 3 times 2. Okay, and then my final thing here, you're good? Oh yeah, so that's the last thing that we're going to do. We're just going to simplify these z's. Now guys, if these are all next to each other, what is the understood operation? It's understood that we're multiplying all of these things, right? So I can actually multiply these two guys, and when we're multiplying, we keep the base and add the exponents. So I'm going to get 1 over, and usually we would write our variables in alphabetical order, just so we all have a consistent way of expressing. So I'll do w first and then z to the 8. Is it really that big of a deal that we do that? Not really, but just so we all are kind of doing the same thing, we'll just try to do it alphabetically if we need to order them. Any questions on that one? Okay, good? Okay, we're amping it up a little bit. Okay, so my first thing that I will always do when I'm working with anything with radicals in it is I want to switch those radicals into rational exponents. My goal here at the end of these 2 questions is to have all common variables gathered and to make sure that I don't have negative exponents in my final answer. And then at the end, we're going to switch things back into their radical form. Okay, so 3 goals. Gather all alike bases, so all x's and all y's in the first one, and then all m's in the second one, and p's and q's. No negative exponents, and then back into radical form when we're done. Okay, so first things first, let's switch all these rational things into, or these radicals into rational exponents. Be aware that the square root stops here. Okay, it's not over the y squared part. And I also do not want to multiply that y squared in because this is technically an exponent. So I can't do multiplications before I do exponents. So I need to take care of this radical first. So x to the 2 over 3, and then y has an imaginary exponent of 1 there, so it'll be y to the 1 over 3. And then I still have the y squared there. Again, we need to just remember that it's understood that these things are being multiplied on top, right? Because they're all next to each other. Okay. So far, so good? All right, so let's talk about the y's for a second. The y's are being multiplied. When I have two alike bases that I'm trying to combine and they're being multiplied, what do I do with their exponents? Kendall? We add them. Okay, so I need to add 1/3 and 2. When I add fractions, I need common denominators. Okay, so what's the current denominator of 2? 1. Okay, good. So I need both of these. I think the common denominator between 1 and 3 is 3, right? So I'm going to multiply the bottom of this and the top of this guy by 3 so that I can get a common denominator, because eventually I have to add these. Sorry. Okay, now let's talk about the x's here. The x's are two alike bases that are being divided. So what am I going to do with their exponents? We're going to subtract them, right? Quotient rule is we keep the base and subtract the exponents. So I'm going to have to do 2/3 minus 3, which means, again, I need to have a common denominator. So this 3 currently has a denominator of 1. And actually, it's going to be the same denominator as the y's because this one's 3. So I need this one to also have a denominator of 3. So I'm going to multiply the top and the bottom of that guy by 3 as well. All right, so here's what we've got. We've got the same two first terms. And x is now 6/3. And the bottom, y. And the bottom x is now 9/3. Okay, maybe we'll do these guys one at a time. Let's do the y's first. The y's, because they're being multiplied, I'm going to add their exponents. So I'm doing sorry, I just wanted to change that. So I'm doing 1/3 plus 6/3. What do I get when I do 1/3 plus 6/3? 7/3. Good. Okay, now we'll take care of the x's. The x's are being divided, so I'm going to keep the base of the x and I will subtract the exponents. So it'll be 2/3 minus 9/3. Y will stay where it is for now. Negative 7/3. And y is positive 7/3. Okay, and then I want to eliminate negative exponents, so the thing with the negative exponent must go into the denominator. And then my last step here is to change the rational exponents back to fractions, back to radicals. So it'll be cube root of y to the 7. And cube root of x to the 7. And because these have the same root on them, we can actually technically just write this as like the cube root of the whole thing, right? Like the cube root of y to the 7 over x to the 7. We don't need to write them separately. So that would be the final answer there. Joey.
If we didn't do that last step, would we have lost marks?
This one?
Yeah, those two.
Well, I do want you to express it back in radical form. Now that you know to do this, just look out for it.
Yeah.
There'll be one in your assignment that you'll notice. Okay? Okay, let's do the second one, and then we're going to start our assignment for today. Any questions? Any other questions on this one?
Can we take some more questions?
How about we just connect after? Just because I want to make sure that I get the assignments out. Okay, so first things first, I'm actually just going to apply power rule here, and I'm also going to take a couple steps to change all of these guys into their fraction exponents. Okay, so power of a power, I'm getting m to the negative 6. Imaginary 2 is out front of both of these square roots on top and bottom. So this will be times m to the 4 over 2 over m times p to the 1 over 2 and q to the negative 3 over 2. Okay, there are many avenues that you might take from here, depending on how you decide to kind of move forward with it, and there could be multiple ways to get to the right answer. So what I might do just quickly here is move the things with the negative exponents to the opposite sides, and I'm going to reduce the 4 over 2 to 2. So I'll get m squared times q to the positive 3 over 2, because I switched its location, and then I have m to the positive 6 times m times p to the half. Okay, Lise? So 4 divided by 2 is 2. Okay, and then I have some m's that I can gather on the bottom. They're being multiplied right now. So I have 7 m's on the bottom total. I have 6 and 1. Okay, let's just do a balancing thing. I don't think it's necessary for us to do quotient rule for the remaining m's. I have 7 m's on the bottom, and I have 2 on top, and I'm canceling 2 from each. So what's left? 5 on the bottom. Good. So I think we can just kind of think about it that way. Just kind of use our common sense there in balancing that guy out. Okay, and then our last step is just to switch these guys back into their radical form. So if I have a denominator of 2, those are actually just square roots. So I'm going to have square root of q cubed, and then m to the 5, that's not a rational exponent, so that doesn't change, and then the square root of p. Okay, I shouldn't be writing anything outside of these roots because, again, we understand that if we write a regular square root that there is a 2 there. And I also don't need the exponent of 1 on this p because, again, that's an understood thing, so don't write those things. Okay, and we have no negative exponents, so we're good to go. Any questions for that guy? Elise?
So you can just get rid of this off
I'm not getting rid of it, I'm just combining them, right? So in a sense, I'm balancing, but if you really want, you can use quotient rule here, right? Like you're going to get m, oh, why do I keep writing x? So used to writing x. I'm doing m to the 2 minus 7, and then m to the negative 5, and then I'm moving it down into the denominator to make it positive. So that's kind of what we're doing, but I think if we think about it like balancing, it's a lot easier and quicker. Good? Okay, so here's the deal. We are going to do an assignment. Actually, I'm just going to stop.